Water pollution is a popular topic that remains under discussion and research in modern times because it has harmful impact on the ecosystem and all living things, including human. Hi and Assalamualaikum to my viewers. My name is ARIEZA binti Zainurin. I am third year student chemical industry and my title for my proposal is free-base phosphorine as a chemical props for heavy metal ion detection. So, water pollution occurs when contaminations pollute water sources, making it unsuitable for various activities such as drinking, cleaning, cooking, and other activities. Heavy metals are among harmful pollutants in water system, which has grown to be an issue in worldwide significance was being addressed by a variety of research methods. They came from various human activity which include mining, smelting, and industrial discharge. Heavy metal pose a toxic danger to human beings even at their minute concentration. So current methods of detection suffer from numerous limitations such as complicated sample preparation, high-cost instruments. So this challenge makes chemists unsuitable for in-situ and real-time monitoring of the sample. All of it, fluorescence spectroscopy has emerged as an alternative for sensing applications. They have high sensitivity, good selectivity, and only requires small amount of fluorescence probes. So in the study, free-base phosphorine are selected to be a fluorescence chemical props. So in recent times, issue of water pollution has gained significant attention globally.
It is observed that the demand for raw water sources increases from time to time for the needs of
conventional methods such as inductively coupled plasma, atomic emission spectroscopy, and capillary electrophoresis for detection heavy metal ions is no longer meet the increasing demands of the community because that method has a high selectivity, but this detection need a longer time, expensive, and a large equipment. But there is also a challenge to choose a suitable chemical props, and one of them used is phenyldiamine as a recognition site lacking specificity. So as a result, this study will look forward for free-base phosphorines as a chemical props. Okay, so for the objective, first we need to synthesize the free-base phosphorine, and the second is we need to characterize the THPP using Fourier transform infrared spectroscopy and also nuclear magnetic resonance. So and then for the number 3 is to evaluate the selectivity of THPP towards heavy metal ions which are nickel and lead ions using steady-state absorption and fluorescence technique. Okay, so in this scope of study, we divided to 3 main parts that can be stated as synthesis of the chemical props. So which are the first? Free-base phosphorine. It is the process for synthesizing of THPP with several steps. Okay, for second part is to characterize the THPP using FTIR, proton NMR, and also carbon NMR. So for the third part of the study is to determine the selectivity of THPP. And for this stage, the interaction between THPP with the nickel or lead ions can be determined. So the presence of it in the surface water or groundwater can be attributed to the discharge of industrial and domestic effluent into water bodies or the leaching of acid rain from soil. Lead contamination in drinkable water is primarily caused by the lead piping system. For the nickel, it is hazardous metallic species that is non-degradable and released into the environment by business involved in the production of steel, batteries, and electronics. So the long-term exposure of the toxic metal ions to the body will cause this ion to be stored in the tissue, causing injury to vital organs such as brain, lungs, and kidney. Okay, so for the methodology, the material used are nitrobenzene, propionic acid, glacial acetic acid for hydroxybenzaldehyde, pyrrole, petroleum ether, chloroform, and methanol. Okay, so for the first stage, it's about the synthesis of the porphyrins. Silica column chromatography with size 100 to 200 mesh will be used to do the purification, and chloroform was used, followed by the chloroform with 25% methanol. Okay, so for the second part, it is the characterization of the porphyrins using nuclear magnetic resonance NMR. So it will use for the characterizing the properties of the synthesis material. Okay, so for the third stage, fluorescent techniques and steady state absorption will be used to examine the selectivity of porphyrins toward existing metal ions with like nickel ions and lead ions in water. Okay, so for this part, the estimation of the binding constant between the THPP and the nickel metal ions in both represents and the absence of nickel metal ions can be identified based on the analysis of the scattered plot. The determination of the binding constant for nickel ion can be achieved through the analysis of the absorption value. The absorption of the isobastic points can be done upon the addition of minimized quantities of lead ion. NMR spectrum of THPP dissolved in DMSO was analyzed. The spectrum exhibits signals within the phenyl ring region. The fluorescence spectra of determining the selectivity of THPP are analyzed, and it can be found that THPP can be represent the fluorescence quenching of 676 nanometer and 708 nanometer. In addition, a faint emission band at 600 to 620 nanometer can be observed. The experimental results indicate that the fluorescence spectra of THPP for nickel ion demonstrate a minor reduction in the intense and wide emission band within range at 650 nanometer to 720 nanometer, accompanied by the emergence of a feeble peak at 600 nanometer to 620 nanometer. Okay, we have came to the end of the presentations. By the way, this is my Gantt chart. Okay, that's all from me. Thank you for your time.